Okay, 5-3 solving trig equations. Number 1, 2 sine of x minus 1 is equal to 0. I need you guys to go back on as much of your Algebra 2 concepts as you possibly can in your brain. So how in the world would you solve this if this would just be 2x minus 1? Okay, I want you to take out the trig functions in your brain and ask yourself, how would you solve this? If it's squared, then make that an x squared. You with me? Okay. If there's two different trig functions, pretend one's x and one's y. You with me? And I need you to pretend, what would you do if there would be just no trig functions in there? How would your algebra skills kick in to solve this problem? So you're telling me I need to go ahead and add 1 to both sides. So I have 2 times the sine of x is equal to 1. Then what? Divide by 2. So I have the sine of x is equal to 1/2. Now I need your trig functions to kick in. So if I need your trig functions to kick in, what would I do with this problem? Okay, so I need your brain, yes, it is the arc sign, but I don't want you to physically write it. I want you to say, okay, what trig function has a sine value of positive 1/2? Okay, well that means I'm plus, plus, minus, 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 and plus, minus. I'm talking sine. Sine is positive in quadrant 1 and in quadrant 2. Would you agree with me? Now, according to the hands of the clock, 1/2 square root of 2 over 2 square root of 3 over 2. What trig function has a sine of 1/2? 30 degrees. So in quadrant 1, I'm 30 degrees. And in quadrant 2, what trig function would I be? $150. Let's go. Okay, this is the same thing as pi over 6, and this is the same as 5 pi over 6. Okay? However, tonight's homework says to just solve the equations. It says to just solve the equation. It doesn't give you an interval on which to solve the equation on. And what it's asking for is all of the answers for every revolution. You with me? So what this means is it's going to take your pi over 6, and then it's going to add 2 pi k to it. Why 2 pi k? What's the 2 pi represent? A full revolution. What's the k represent? The number of revolutions you're traveling. You with me? Okay. So that's going to mean all of the 30-degree angles. And then 5 pi over 6 plus 2 pi k is going to represent all of the other 150-degree angles with revolution k. You with me? This is going to be like problems 7 through 16. That's the format that they want your answers in for problems 7 through 16. You with me? Okay. Number 2 example. And this is actually number 22 out of your textbook. Just so you're aware, this is problem number 22 out of your textbook. Okay? The directions in your textbook for problems 17 through 30 say, find all the solutions of the equation on the interval 0 to 2 pi algebraically. What does that mean, 0 to 2 pi? I'm sorry? 1 revolution. Does it want any other revolutions? No, it wants only the answers from 0 to 2 pi and only those answers from 0 to 2 pi. Do we all understand that? Okay, so I want you to go ahead and I want you to solve this. Now, how do I go about doing that? What do you notice? Come on. Read the problem. 2 sine squared equals 2 plus cosine x. What do you notice by trig? Nope. What? There's 2 trig functions in it. I had 2 of you say that there's two different trig functions in it. Is that helpful whenever we're solving equations? No, it's not helpful at all. So I need to utilize my trig identities So I can make a substitution so that I have only one trig function in there. So what trig identity do you think that we would utilize? Sine squared x plus cosine squared x is equal to 1. What do we want to utilize in that? How do I manipulate it? What do I want to manipulate it to do? You found the trig identity, but what do I do with it? Okay, my problem is 2 sine squared x plus 2 plus cosine x. How am I utilizing sine squared plus cosine squared equals 1 in my problem? I'm trying to get rid of which function am I trying to get rid of? Is cosine in here? Cosine squared is. Sine squared is what I have to manipulate. Do we understand that? Yes? So what I want to do is I want to take this function that I have over here, sine squared plus cosine squared equals 1, and I want to solve it for what? For sine squared. So if I do that, sine squared of x is equal to 1 minus the cosine squared of x. What does that mean I can do with that trig identity? I can plug and chug the expression of 1 minus cosine squared in for sine squared. So this is going to be 2 parentheses, 1 minus cosine squared of x is equal to 2 plus the cosine of x. Do we all understand that, yes or no? What I'm doing is I'm essentially getting rid of it. Devin? So if I distribute this, I have 2 minus 2 cosine squared of x is equal to 2 plus the cosine of x. When solving equations, what's our first step you should always do? Foundational information. Whenever we go back to our Algebra 2 skills and we're solving equations, what did we always have to make them do first? Set them equal to 0. Is this equal to 0? How do I do that? Come on, words, talk. Worst thing that can happen is you're wrong. It's okay to be wrong. You have to learn from it. So tell me, blurt out what you think we should do. Subtract 2 and what else? So we're going to subtract 2 and subtract cosine of x. Subtract 2 and subtract cosine of x. Notice I put a little space here. Why did I put a little space there? Because they're not like terms, are they? So 2 take away 2, that goes away, but I'm left with negative 2 cosine squared x minus the cosine of x is equal to 0. Yes? Okay, now what? Okay, I want you to pretend that you'd have negative 2x squared minus x is equal to 0. What would you do if you had that? Get rid of the trig in your brain and go back to foundations. If you had the red, what would you do? If you would have the red equation, what would you do? No. Why? Because this is x squared and that's x. What? Factor it. What would you factor it? How would you factor? What would you do to factor? What'd you say? Take an x out. Okay, so if you're going to take an x out over here, what would you take out in our trig function problem? You would take out a cosine. So if I take out a cosine of x, and not just a cosine, but a negative cosine, I'm going to be left with a 2 cosine of x plus a 1 is equal to 0. Yes? So in my problem over here, I still have the same exact philosophy. Yes? Look at my red function over here. What would you instinctively want to do now? Who says distribute? If you distribute, you're going to go right back to the original. You're working backwards. You're not paying attention. So what should I do? If I'd have this red problem over here, what would you do? Can't hear you. Nope. Can't subtract x. It's attached by multiplication. No. Come on, guys. Think. You know algebra. After you set it equal to 0, and after you factor, what do you do? Okay, what if I were to have this? What would you do there? You'd set them both equal to 0, right? You'd set them both equal to 0. So let's go over here. It's the same exact concept. I just gave you two binomials where your brain was able to be like, oh, set them both equal to 0. This is a GCF. So set your GCF and your parenthesis equal to 0. This is a GCF. So I have negative cosine of x is equal to 0, and 2 cosine of x plus 1 is equal to 0. Yes? This is all algebra. You have to recognize the algebra. So if I solve this small equation over here, I have the cosine of x is equal to 0. So where is the cosine of x equal to 0? What does x equal? When is cosine 0? At 90 degrees, which is what radian measure? At pi over 2. And where else is the cosine 0? At 3 pi over 2. How do I solve the second part? 2 cosine of x is equal to negative 1. Divide by the 2. Cosine of x is equal to negative 1/2. Right? So I have plus plus, minus plus, minus minus, plus minus. Where is my cosine negative? Quadrant 2 and quadrant 3. What angles has a cosine of 1/2? The angle in quadrant 1 that has a cosine of 1/2 is 60 degrees. The 60 degrees is the reference angle. So if I'm in quadrant 2, the angle that is a 60-degree angle is the one that hovers around the y-axis. So that is going to be 2 pi over 3. And what is my other one that hovers around the y-axis in quadrant 3? Remember, this is 3 pi over 3, so that's going to make that 4 pi over 3. Those are my two other angles I'm going to have, yes? Do we understand that, yes or no? And again, that's like 17 through 30. Okay, so let's do another one from that section. This is another example. This is actually number 28. I chose examples from your homework that were even problems. Okay, talk to me. When you're solving equations, setting it equal to 0 is crucial. Is the set equal to 0 already? That's very, very important to us. Okay, but before I can start this, what do you notice about this problem? There are two separate trig functions. Do we like having two different trig functions? No. Can I manipulate that in any way to not have two different functions? How so? I go back to what I know. Sine squared of x plus cosine squared of x is equal to 1. There's the trig identity that I need to utilize. So what am I going to do to that trig identity? I'm going to solve it for sine squared. So sine squared of x is equal to 1 minus the cosine squared of x, correct? Okay, what do I do with that now? I plug that in place of sine squared. So I'm going to have 1 minus the cosine squared of x plus the cosine of x plus 1 is equal to 0. Do we see that, yes or no? Now what should you do? What does that give me? Correct? Now, do we like it when our first term is negative? What could you do to make that turn positive? Take out a -1. That makes it so much easier in our brain. So if I pull out a -1, I'm left with positive cosine squared minus cosine x minus 2 is equal to 0. Do you have to do that step? No, but generally speaking, our brains prefer it that way. That doesn't mean you have to. And what do I do next? What was that? 2 binomials is correct. So if I put this into 2 binomials, how do I split up cosine squared? Cosine of x and cosine of x. How do I split up 2? 2 and 1. I need to have a -2, so what's it say about my signs? One's positive and one is negative. So which one's going to be positive, which one's negative? -2, +1. Do we see that? Okay, now what do you do? Set every single thing equal to 0. So if we do that, I have -1 is equal to 0. Is that ever true? No, it's not even relevant to the problem anymore. Cosine of x minus 2 is equal to 0, and the cosine of x plus 1 is equal to 0. Yes? Devin, stand up. That's the second time. What do I do now? Add 2 over. So I have the cosine of x is equal to 2. What angle from 0 to 2 pi has a cosine of 2? You're shaking your head no. Why? The highest it goes is 1, right? It's the unit circle. So therefore, this is not possible. Okay, so come over here. This is going to have the cosine of x is equal to -1. So what angle on the unit circle has a cosine of -1? Which is strictly pi. Does that make sense, yes or no? We good? Make sense? Okay, let's keep on going. What do I do? So if we want to set this equal to 0, what does that mean I do? Setting this equal to 0 means I'm just going to add sine x to both sides. So sine x and sine x give me 2 sine x. Please do not confuse that and make that sine squared. That is not a true statement. Do we get that? Now what? You're good. Tell me what. Subtract what, guys? Square root of 2. My brain does that all the time, by the way. Like, hourly. You're not alone. You're not alone, girl. Okay, what do I do now? Divide by 2. Okay, what is the saying? plus, plus, minus, minus, plus, minus. So tell me, what do I need to do? What trig function has a sign of negative square root of 2 over 2? Sign is negative in quadrants 2 and 3. What angle? Reference angle. I want you to think reference angle. Reference angle is in quad 1. So in quad 1, what angle has the sign of square root of 2 over 2? 45. So I need you to find the 45-degree angles in each of those quadrants. So 45 has a denominator of 4. So this is 4 pi over 4. So what's this one going to be in quadrant 3? 5 pi over 4. This is going to be the 6 pi over 4. So what's that one going to be? 7 pi over 4. Do we understand that? Yes or no? Make sense? We good? Okay, number 5. What do you think we should do? That is equal to 0. How? So I'm going to have the cotangent of x times the cosine squared of x minus 2 cotangent of x is equal to 0. I'm sorry? Combine like terms? Do I have any like terms? But the cotangent of x is attached to this cosine squared of x by multiplication. So in order for this to be added to the 2 cotangent of x, it can't have anything else attached to it. So those are not technically like terms, are they? I need you to think of algebra skills. I like taking out a cotangent much better than what I like doing anything else. Why? If I pull out a cotangent pulled out leaves me with what? Cosine squared of x. Keep going. Minus what? Minus 2. Do we understand that? So now what? Set each one equal to 0. You guys are making a mountain out of a molehill here, right? Yes? If you set each one of these equal to 0, I have 2 separate trig functions no longer attached together, correct? And they're all by themselves. So my question is when do I have a cotangent equaling 0? I need your brain to go back to this concept right here. 1, 0, 0, 1, negative 1, 0, 0, negative 1. And understanding that cotangent is x over y. So what is my x value that has a cotangent of 0? X is going to be where? I'm sorry? And 3 pi. Do we understand that, yes or no? Okay, well, let's come over here and solve this one. Well, if I'm solving this problem right here, what am I going to do? I'm going to go ahead and I'm going to add 2 to both sides. Then what? Take the square root of both sides. So if I take the square root of both sides, I have the cosine of x is equal to plus or minus the square root of 2. Correct? Plus or minus the square root of 2. So what do I do from there? What? It's not possible. We don't know where this happens on the unit circle. It doesn't. Do we all understand that? The square root of 2 is larger than 1. Yes? So by definition, we can't do that. So therefore, my only answers are right here. Now, here's my issue with this textbook. This textbook will do funny things to you. Sometimes it'll use the arc, sine, and cosine inverse functions and say, okay, well, if I'm going to use arc cotangent, that's only defined from 0 to pi. You with me? And it's going to say, we're going to throw this out. But it's not consistent at all. Okay? So I'd rather you list all of the answers, getting rid of the domain range restrictions. And then whenever you check them, you have more than what you need. And you'd be like, oh, well, are you applying the domain restrictions here? Are you with me? Then you not have them be like, well, why does it equal to that? The reason why is it's throwing out those domain restrictions there. Do we all understand that? Okay. And let's keep on going so that you can see another type here. Tonight's homework is this. Let's go ahead and start your homework together so that you know what you're doing. Tonight's homework is 7 through 37 odd. So we're going to start problems 1 through 7. The directions, I'm sorry. I don't want to do problem 1. I lied. I don't even want to do that one. I'm losing my mind. This is number 7. That makes more sense, right? This is actually problem number 7. It says solve the equation. When it says to solve the equation, it does not give you an interval. What do you have to make sure that you have? The 2 pi k at the end of it. You with me? Okay, so how do I solve this? Add 1 over. Divide by 2. So if I'm dividing by 2, hands of the clock. Plus, plus, minus, plus, minus, minus, plus, minus. Where's cosine positive? Quad 1, quad 4, right? And what trig function has a cosine of 1/2? Hands of the clock, 1, 2, 3. 60 degrees. What is the radian measurement of 60 degrees? Can't hear you. I mean, come on. What's 60 degrees of radian measure? Pi over 3. And you're simply just going to add the 2 pi k at the end of it. Yes? Now, if it's 60 degrees in quadrant 1, what is the equivalent to that in quadrant 4? Well, help yourselves out. This is 6 pi over 3 because that's 2 pi, and take off pi over 3 units to give you what? 5 pi over 3 plus the 2 pi k. Do we understand that problem, yes or no? Any questions over that? Uh-oh. This is supposed to be plus in this problem. It's okay. Just leave that problem like that. Okay, next one. I don't know. Hold on 1 second. Apparently my numbering is off, which it is. Let's skip. Number 13. We're going to skip to number 13. 4 times the cosine squared of x minus 1 is equal to 0. Hold on 1 second. Four times the cosine squared of x minus 1 is equal to 0. So this is number 13. So how do I solve this problem? 4 times the cosine squared of x is equal to 1. Cosine squared of x is equal to 1/4. Take the square root. So I'm going to take the square root of the top and the bottom. So I have the cosine of x is equal to plus or minus 1 over 2. Yes? So it wants all of the 60-degree angles. Do we all understand that? Yes or no? We good? Now, the way your textbook, you may see this, is what it's going to do is you're going to say that x is equal to pi over 3, 2 pi over 3, 5 pi over 3. I missed one, sorry. 4 pi over 3 and 5 pi over 3. Okay. What your textbook does is, because we're doing quadrants, a lot of times what it'll do is it'll give you just this one, and then it'll say, well, let's add pi k to that. If you add pi k to it, the other angle it's talking about is this one right here. Do you see that? Yeah? So instead of adding 2 pi, it's just going to add pi. So sometimes your answers will look kind of funky like that. And then they'll give you the other one, which is going to be 2 pi over 3. Yes? And instead of saying add 2 pi to that, it's going to come down here and say, all right, well, let's go ahead and make that plus pi k to that one. And that's going to give you the 5 pi over 3 angle. Do we understand what it's doing whenever you get an answer like that? I would be just fine if you give me this. I'm okay with that. But if you give me the pi k from what the textbook gives you, I just am showing you the different notations. We all good on that? Okay. Okay. Basically, that's all I have for you guys today. What's that? Okay, tomorrow you're going to have a worksheet. Yes. And it's for accuracy.